Good morning and welcome to Statistics. Today we will look at Chapter 1, which could just be an introduction. That's really all it is. We'll get some basic vocab, some other stuff. A lot of the stuff you've probably already seen before, but there are a couple little, not really twists in here, but extra little nuggets of information. Now, before I get too far into this, I want to remind you that it is super important to actually do your reading. There are a lot of great details in the book, and I can't get all of them unless you want each of these to be like an hour long. And I don't want to be talking to myself for an hour, and you don't want to be listening to me for an hour. But the book is great. It is very readable. And again, there are times when it is legitimately funny. Um, Probably in a dry math sense, but there are times like just things that they put in there are great. Make sure you read captions and footnotes and stuff like that. So, chapter 1, stats starts here. So the very first question on your mind is probably, what is statistics? That's a fair question. You're in a class called statistics. You probably want to know what statistics is or are. Well, statistics is the study of data and variation. So the data, that's the information that we get. What can we do with it? And then variation is how the data changes from individual to individual, from measurement to measurement. Like everything's not exactly the same. And that's variation. That's what makes life interesting. I know I love statistics because data and variation is in everything. Like this is probably the single most useful class and most universal class that you could take. So, data. What is data? Data is information with context. Notice I said information. I did not say numbers. A lot of people think, oh, well, data, that's just a whole bunch of numbers. No, the color of an apple is data. And so that's a color. Um, and then context is super important because if I say that you are 17, could mean that you're 17 years old. It could mean you're 17 hands tall. It could mean you are student number 17 on my roster. It could mean a lot of things. So having that context is super important. Also important is in statistics, there are really four different things that we do. And there's also four topics in statistics. I guess the four topics, we're going to look at exploring data, gathering data, probability, and then inference. So those are the four topics. The first chunk is on exploring data. But then the other four things that we do is we're looking at what do we have to do, what do we get, then how do we do what we need, and then what does that mean? The how we do what we do, like the actual calculations, are not as important as the other stuff. Computers can do calculations for us, but computers cannot think for us. And the other stuff is the pieces that require thinking. And so this brings us to the 5 W's. And these are the 5 W's of journalism, you've talked about it in English if you're writing an essay or analyzing an essay, the same 5 W's. The who, the what, the when, the where, the why, and the how. 1, 2, 3, 4, 5, 8, yeah, that checks out. So, in this, the who and the what in statistics is essentially important. We need to know who we're talking about and what we're talking about. Those are the two singularly most important pieces of the context. The others are also important. The when. If we're looking at median household income data, was that collected in the past 5 years, or was this collected in the early 1800s? The data is going to be very different between those. And so knowing when can be important. A lot of times it gets, it'll be footnoted where you can see like, oh, this study was taken here, or it'll be just assumed that it is current data. And assumptions are not good in statistics, because that's when somebody slides in old data and, oh, everyone assumes it's current data, and it's very misleading. I'll say it a number of times this year. I'll probably even say it again today, that there is good money to be made in doing good statistics, but there's also really good money to be made in doing bad statistics. Getting bad data. It's a thing. Anyone in advertising gets data to make themselves look good, or their company look good, or their candidate look good. And so the when is important. The where is important. Is this median household income for upscale New York? Is it for Nebraska, like in the middle of nowhere, Nebraska, not the towns? Or is it from like the jungle of Kenya? Those are going to be different things. So knowing the where, is this like the full nation? Is it the state? Like, what are we talking about here? The why is important to know. Why was it collected? A lot of times that can get answered by knowing who collected it. Was this information collected by the Toyota car company? Was it collected by the Ford car company? My guess is that those two companies would come up with vastly different data that would make each of them look good. And so knowing why data was collected, hopefully the data was collected by a third party that has no interest in one side or the other. And that's what good data comes from. And then how it was collected. What type of method? Was it a voluntary response survey? Was it a good experiment? Was it an internet poll? Different methods of collecting data yield different results and vastly different quality of results. And we will talk about that later on when we're talking about collecting data. So the 5 W's are important, but specifically that who and the what are super important. So next we're going to look at some just basic vocab. I may have used some of these words already, haven't been paying attention. Respondents. A respondent would be someone who responds to a survey. So it just makes it so we don't have to say people who responded to the survey. We can use respondents. Experimental units are things that were used in an experiment. If you are growing plants and you're testing the types of soil, each of the plants would be an experimental unit. Now, people tend not to like to be referred to as experimental units. They feel it's dehumanizing or something. So to make them feel better, usually for people we call them subjects or participants. Variables would be the data that's being collected. Again, it could be numbers, could be colors, it could be all sorts of stuff. And we're going to talk about the different types of variables and data on the next slide, actually. The population. The population is the entire group that you are trying to define. Now, or trying to describe. Now, the entire group does not have to be huge. Like it could be the population of the United States. It could be the population of the world. It could be the population of Washington. It could be the population at Stanwood High School. It could be Stanwood High School seniors. It could be the Stanwood High School seniors in AP statistics. So your population can change drastically. Your population also doesn't have to be people. It could be corn. Your population is corn. Your population is grains of rice. Your population is redwood trees. And so your population could be anything, but it's what you're trying to describe. The sample is that piece of the population that we actually observe. Um, Sometimes, like if we were talking about the seniors in AP statistics, we could probably just ask all the seniors whatever we wanted to know. And then that actually isn't a sample, it's called a census. When we ask the entire population, it's called a census. Um, but there are times when we can't just ask every single person. For example, if we were talking about if the population was the people living in the United States of America, you can't ask every single person. They try every 10 years. It's the census. And there's a reason why it's only done every 10 years. It's very, very time consuming, and it's also very, very expensive. And so instead of asking everybody, we ask a small group of those people who are hopefully a good cross section that will let us know, or it will at least give us an idea of what everybody thinks on an issue. And that's what a survey would be, or even an experiment. But the people that we ask are the sample. And again, we'll talk about this a lot more when we're talking about gathering data, but knowing what these are is important because it means we can talk about them. Now, this book, specifically like this textbook, has a great 3-step process that they go through for every question. The first step, you have to think about what is the problem? What are you trying to say? And then show what you have found. And then finally, tell what you have learned. Now you might think, wait, showing what I found and telling what I learned is kind of the same thing, but it's not. Showing what you found might be a graph of your data, which we'll look at in the next chapter. Telling what you learned is, what does that graph tell you about the population, about the problem that you were thinking about? It takes thought. It takes, you have to interpret it. It's not just, hey, I found this graph. I learned this graph. You didn't learn the graph. You found the data that made the graph, and that taught you something about the population. Maybe it's that there was no consensus and everyone was completely different. I don't know. So, types of data. Now, the types of data, there's always two that everyone always knows it too. Oh, it's categorical and quantitative. We learned these back in elementary school. Well, it's a little bit tougher than that. There's actually a third category. The third category is identifiers. Now, identifiers are basically data that's useless. What do I mean by data that's useless? I mean, no data is useless, but it's useless out of its context. For example, if I collected everyone's phone number or everyone's email address, that's great. It identifies you as you. Like, that is a piece of data attached to you, and I could call you or email you with that. So it's not useless, but outside of that, it is. I'm not going to find the average of your email addresses. I'm not going to find the average of your phone numbers. I'm organizing them in any way would be pointless. So other than that, it's basically useless, and that's an identifier. Your student number in my roll book is an identifier. It identifies you as student number 17. The example they use in the book, they were looking at Amazon orders, and you are Amazon order number, then like a string of 17 numbers. That's great. It helps Amazon, but other than that, it's not really worthwhile data. So we don't do anything with identifiers. Categorical variables. It's data that groups individuals into different categories. A lot of categorical variables are non-numeric. Color will be a categorical variable. Favorite type of pizza is a categorical variable. But some categorical variables are numeric. Um, your grade in school, like 9, 10, 11, 12, it groups you into a freshman, sophomore, junior, senior. Your area code, it groups into regions. Like our region has a couple area codes. We have the 360 area code. We have the 425 area code that I think is mostly cell phones. But it groups into regions. If you go down to Oregon, you're not going to find someone with a 360 number. And so those are categorical variables. A lot of times categorical variables can't really be put into any order. That's not entirely always true though. For instance, the 9th, 12th, 11th, 9th, 10th, 11th, 12th makes more sense in that order than whatever order I just tried to say I'm in, as I was getting confused while talking. So those are categorical variables. The other type are quantitative, which is a measured numerical value with units. It has to be numerical and it has units, but it's measured. It's something where you would take an average of them and get a useful piece of information. And so those are the quantitative. And generally speaking, categorical or quantitative, usually it falls into one of the categories or the other, and it's not that tough of a task to separate it. However, sometimes it could be both. Sometimes, depending on the context, it could be either. Your age, for example. If I was to get the age of people in this class, it would probably be a categorical variable because you're going to be one of just a couple different categories. If I was to get the age of everybody in Stanwood, it would be more of a quantitative thing. Because there's so many more values, it becomes more of a continuous rather than a discrete variable. However, I could use the age in the classroom as a quantitative. I could find the average age. Just like in Stanwood, I could find the age and use it as categorical. In that case, I would probably group people into age brackets, age ranges. We have the 0 to 9, the 10 to 19, etc., etc. And then I'd have each of those categories. But that's just to point out that sometimes it could be either categorical or quantitative. You have to look at the context, what is being asked of the problem. That's that think part of that think, show, tell. And the very last thing we're going to look at the end of the chapter, at the end of every chapter, there's this little box of things that can go wrong. I wanted to make sure I pointed this out because a lot of times we focus on what we know and what we do, and we never think about what are those really common mistakes that people make. And so I love that it has this here. I might continue putting them in to here, but again, you should be reading the book, so you should be seeing these. I just wanted to very much point this out today. So what could go wrong? Don't label a variable as categorical or quantitative without thinking about the question you want to answer, because sometimes it could be either or. Just because it's numbers, don't assume that it's quantitative. If we were on a 5-point grading scale, you got a 1, 2, 3, 4, or 5. Those are numbers. Are they quantitative? No, it's kind of a category. But on the other hand, I could also find the average of them, so it could be either. What is the context of it? And then be skeptical. One reason to analyze data is to discover the truth. Even when you're told a context for the data, it may turn out the truth is a bit or even a lot different. And think about how and why the data were collected. If the data looks like it's unbelievable, either because that is so far outside of what you would have expected, or because the data perfectly aligned with exactly what you expected, like a too good to be true type of thing, I would look at the context. It might be that the data is true, perfectly legitimate, and that's just how it is, and either you were very right or you were very wrong, or look to see what it was. Um, hey, we're in the middle of an election year. The data collected by Trump's campaign and the data collected by Biden's campaign are probably going to look a lot different. Are either of those two going to be perfectly true? Probably not. I'm not picking sides here. I'm just going to say, like, both of them are collecting data that makes them look good. That's what they're getting paid to do. Not them, but the people collecting the data. They don't collect their own data. They have people to do it for them. Um, and so they're paid to collect data to make them look good. So anytime you see data that's either too good to be true or doesn't match with what your experiences are, take a second look. Look at the context to see who was collecting it, why it was collected, how it was collected. So it will help you to keep from being quite so misled. Anyway, that is chapter 1. The assignment for this chapter, it's super easy. It's like, is this categorical, quantitative, things like that. I mean, it's a fairly easy topic. It shouldn't take too long to do that one, but do make sure that you get it done. Also, remember to make sure you take the quiz on Wednesday. Until then, I'll see you in class. Until then, keep working problems, keep asking questions, and as always, happy mathing.